air pollution is the second largest killer in the world. Over 8 million people in 2021 died. Their death was attributable to air pollution. It's second behind malnutrition in terms of risk factors. So this is a really large issue, and one that I'm particularly interested is the impact on children's health.
Hello, and welcome to Engineering the Future, a show from the McKelvey School of Engineering at WashU. This season, our theme is Engineering Human Health. I'm Sean Ballard, a science writer here at McKelvey, as well as an engineering enthusiast and part-time podcast host. Today, I am here with Jay Turner. Jay, who has many titles, including Professor of Energy, Environmental, and Chemical Engineering, Head of the Division of Engineering Education, Vice Dean for Education, and the James McKelvey Professor of Engineering Education. Welcome, Jay.
It's a pleasure to be with you today, Sean.
Well, I am delighted to get to talk to you about many of these roles, all these hats that you wear here at McKelvey. But I want to sort of jump in broadly, focusing on the environmental and chemical engineering aspect. And you work on air quality characterization and management. That seems like a very big, very complicated topic. Could you break that field down for me a little bit?
In this case, really what we're looking at the interface between the engineering science and the regulation and policy is how do we lay the science-based evidence for effective and appropriate policies and regulations. Okay. At the end of the day, it is a policy decision, such as whether or not to introduce a new air quality standard, to tighten an air quality standard. It's a policy decision, but that decision needs to be based on really sound scientific evidence. That's where the work of like myself and others comes into play.
Specifically in your lab, right? You're doing that research part. What does that look like as you're thinking about, here's what we're doing, but how that might sort of impact, real policy going forward?
So whether it's policy or whether it's just more broadly air quality management, we quickly get into situations that are very case-specific, very site-specific. So the type of work we often do in my group is to really uncover what are the true dominant sources contributing to an air pollution problem in a specific location. Often it's in even a specific urban area. And so that the local government, the state government, working with federal government oversight, can really tune up or optimize how to best spend every dollar towards getting the maximum reduction to protect health.
Okay. So yeah, thinking about that that health aspect. I know you're a chemical engineer by training. How did you get into that environmental and human health side?
There's actually a few different angles on that. One was actually my very early start. I was an undergraduate at UCLA, and I would look to the east and see this incredible smog. But I was also racing sailboats for UCLA, and we would go off the coast, and I would look back where the campus was and realized, wait, it's smoggy there too. At the time, I began to understand that our visual perception of air pollution was not necessarily aligned with what we were actually experiencing.
Okay.
Overlay that on another undergraduate experience as a sophomore. I took a course in patent law. And in that patent law course for engineers, the instructor gave me liberty to look at a topic that was outside of patent law, and I looked at acid rain. And part of my motivation was in my early years, I was in rural Pennsylvania, and my eyes burned often when it rained. I didn't know why at the time. I later learned it was acid rain. Right? So it was this conglomeration or this nexus of lived experiences that got me really interested in this topic. Ended up in a research lab as an undergraduate. The rest is history.
And then how did you get here to WashU, where you did your PhD work, right? And now you've come back as a faculty member.
That's correct. So I did my doctoral work here because I had the pleasure of working with this really talented chemical reaction engineer. So this is hardcore chemical reaction engineering.
Okay.
Because I really at the time thought I wanted to go into industry. And my doctoral work was focused on things that could go wrong when you're doing air pollution control at the actual control device level. Right? But along the way, I got this bug for the teaching and the academic research and ended up in an academic position.
Was it the teaching, that you mentioned you really enjoyed being in an academic setting, or was there something else with sort of the questions you were able to answer that really drew you back to sort of lab work?
It was multi-pronged.
Yeah.
One was I enjoyed the teaching, for sure. I had the opportunity as a graduate student to do some teaching, and I enjoyed it. But another was that my advisor actually gave me the liberty to explore the policy aspects of what I was doing. Because at the end of the day, most of the controls that we do for the environment, it's technology forcing, regulations that are technology forcing the design or development or optimization of control technologies. So understanding the policy context for controls was something that really interested me. He gave me the liberty to spend a significant amount of time understanding that policy context. And going forward, that's where my interest really shifted then to air quality management, was how does that science and engineering and the policy and regulation come together?
Okay, so I'm hearing you seeing an opportunity to have a potentially larger impact than sort of just one person working in industry, really being able to, as a researcher, influence the sorts of decisions that are made broadly across industry with potentially really large human health impacts, right? Can you tell me more about what kinds of health impacts air quality really has for us folks who are out here, experiencing that acid rain, experiencing that smog? How big of an issue is this that you're now sort of deep into?
It's a huge issue, and they're multifaceted. It affects largely every part of the human body. We often think about air pollution as respiratory. Turns out the particle air pollution that a lot of us here at WashU focus on affects the cardiovascular system more than the respiratory. But there's even a lot of emphasis on understanding the effects of air pollution on neurodevelopmental diseases or illnesses such as autism and Alzheimer's, and also neurodegenerative diseases. We're collaborating on work in my group looking at Parkinsonism and the effect of air pollution on being a risk factor for Parkinson's disease.
Oh, wow. Okay. I would not have guessed that a bit. So air pollution dealing with cardiovascular health, how does that connection happen? I think I breathe it in, which of course our systems are connected. But what's really the mechanism for that?
There's so many different mechanisms for it. There really are. But one common thread we see across at least some of the mechanisms that leads it to affect the respiratory system, the cardiovascular, the neurological system, is simply inflammation. Air pollution can cause inflammation, and then that can have a cascade of other effects that get manifested through what are the more common illnesses, diseases, symptoms that we might see expressed. So air pollution is the second largest killer in the world. Over 8 million people in 2021 died. Their death was attributable to air pollution. It's second behind malnutrition in terms of risk factors. So this is a really large issue, and one that I'm particularly interested is the impact on children's health.
Okay, so let's dig into that. So you mentioned, that's a huge, disease burden worldwide. What does your work look like kind of at that global scale? Like where, what are you up to out there, Jay?
It really varies depending on the setting. In the past, on the global scale, for example, we've had the pleasure of working closely with the Hong Kong government and a Hong Kong university, and really trying to understand what's really the drivers for the air pollution that was being experienced in that setting. How much was local? How much was regional? How much did they really need the Chinese central government in Beijing to have nationwide policies or regulations that would then affect the air quality way down south in Hong Kong? A lot of my work, more interesting though, is in other countries such as Mongolia and now especially Central Asia. And there, the scale's different. The cities are much smaller. They often don't get nearly as much attention as the mega cities. Like right now we see New Delhi all over the news. But to the people who live there, it's just as important.
Right.
And so the types of things that we're trying to do in these settings is, again, on the air quality management side, we're really trying to understand that the priorities are placed on the addressing the pollutants and the emissions that matter the most. It's really easy to get distracted in an air quality management framework to do things that are easy as compared to things that have the most impact.
Oh, can you unpack that for me some more? Like, what are some examples?
So as an example, just a few years ago in Bishkek, Kyrgyzstan in Central Asia, they were looking at the air pollution problem there and reached the conclusion that the largest contributor to their wintertime air pollution was most likely due to cars, due to a centralized power plant, coal-burning power plant in the city, and the largest landfill in Central Asia. through the work that we were involved with, as well as the work of others working in parallel to us on complementary projects, we all came to the conclusion at the same time that none of those were the largest sources of air pollution. It was actually residential coal burning in the city, people burning coal in their homes to keep warm, that was causing a neighborhood scale air pollution effect that was having the biggest impact.
That's
So
incredible.
the ability to take the science to shine a bright light on where the priorities need to be for controls.
Okay. I want to kind of just restate there because what you said sort of like blew my mind a little. So it wasn't, we sort of, in a city, I can imagine seeing a big power plant or thinking like, oh, there's all this congestion on the roads. Those are very easily identifiable, right? That smog that you could see, right? You mentioned early, but it's not those things, right? The things that sort of appear to be the biggest is actually these super local sources of pollution. That's what you found?
It really depends on the setting.
Yeah.
And indeed, to be clear, those other sources are important, but they're not dominant.
Okay.
In the areas of the city where the air pollution is the worst. And so it's really a matter of, often what happens is people see the visual plumes from smokestacks or from, again, a really large landfill or from the tailpipe of a car. But they'll look at, say, a chimney from a home a little differently. But if you put 10,000, 100,000 chimneys out there, you've got a lot of emissions.
All over the world where you've seen different sources of air pollution being more important. I want to jump back here to local, right? St. Louis, thinking about the air that you and I are breathing when we're out here at work. How do those lessons that you've sort of picked up from all these places where you've worked, globally, Hong Kong, Central Asia, how do you bring those back? And how similar are the questions that you're asking right here in our local community?
The questions are different because we're at very different places along the air pollution control trajectory.
Okay.
And we're dealing with pollution levels in some of these cities that I've mentioned in Asia in the wintertime that are so much higher than what we experience. Whereas here, on most days, we don't even visually see the air pollution.
Right.
And although we may be at or even above an air quality standard, yet we don't see it. So we're in different places. We're needing to take a finer scalpel to reducing the remaining emissions to get to where we want to be with regard to air pollution control. 20 years ago, it was not as extreme as what I've talked about in Asia, but it was certainly more visible. And it was honestly a bit more straightforward in terms of what we needed to do based on the type of studies we would do.
Okay.
Our scalpel didn't need to be as sharp. It could be a little more blunt, and we could still work on addressing the problem.
Okay. What did that trajectory look like? So I'm thinking here, I'm aware of like a lot of traffic congestion, for example. That's one I encounter, on my commute and things like that. So thinking of that, like sort of traffic, cars, other stuff on the freeways around here. I have the impression that that's a large source. Is that true? And sort of how has that changed over the course of you've been looking at this for several decades now?
It has changed, and again, it is to some extent setting specific, but there's no doubt almost all sources the emissions have come down rather significantly.
Okay.
Our cars are so much cleaner than they used to be, that's for sure. Diesel vehicles, they have a long lifetime, but the new vehicles that are coming out in terms of their air pollution emissions are almost as clean as a passenger car.
Oh, wow.
So over time, as the fleet turns over, we'll continue to see improvements. Industries had a lot of controls. The air pollution coming in from other parts of the country has been reduced. So it's really been a combination of national regulations, local regulations that all come together in this layered effect to reduce the overall burden.
Okay, great. And I know, I'm glad to hear that as someone who, likes to breathe the air outside here as I'm, biking around or walking around campus. I know that, you've been involved with local groups here, in the St. Louis metro, including the Metropolitan Churches United, as well as other groups. Could you tell us more about that work that you've been involved in locally? I'm so glad to hear things are changing for the better. And I just want to know, what does that look like on the ground right now?
Things are definitely changing for the better, but there's still certainly a lot of room for improvement. So in the particular case of Metropolitan Congregations United, that opportunity, and I consider it an opportunity, was brought to me and my group through the environmental studies program on campus that was already working with them. And they had an air pollution project that they wanted to implement. And they were looking for some support with regard to measurements. So what we did in that particular case was partnering with 14 congregations in St. Louis City and North St. Louis County. We did monitoring at their churches outdoors, focused on the pollutants that were of interest to them. And that's really important as the first step towards building relationships and building trust. At the end of the day, after a year of intensive measurements, we learned that there weren't significant disparities across the area where we were doing the measurement. But that doesn't mean there aren't disparities.
Okay.
There weren't disparities for what we were measuring.
Interesting.
Going forward, there's other types of pollutants where we think there might be disparities, and that's where we're going to take our work going forward.
Obviously, I can imagine that working here in St. Louis, but probably in other settings that you mentioned in Asia and elsewhere. Do you find that local engaged citizen scientist component, particularly powerful, perhaps?
It can be very powerful. For example, I'll take us back to Kyrgyzstan again, where there's a non-governmental organization that is very influential about coalescing people, other organizations, towards putting a spotlight on the air pollution problem and getting the government's attention that something needs to be done. Not surprisingly, initially there was some resistance to them. They actually now have a seat at the table.
Oh, amazing.
Their voice has been heard. That's just one example of several that are out there of citizens, and whether it's citizen science or citizen-based advocacy, there's really huge opportunities for those voices to be heard. It plays out differently because in the U.S., for example, different states have different regulatory structures for air pollution on how aggressive they will go after something if it's not governed by a federal regulation. But there's always opportunity for there to be engagement and to really affect change.
You have worked in several sort of government or government adjacent roles, is that right? So I understand you worked with the Department of Transportation looking at air quality, and then of course you've been sort of an advisor with the Environmental Protection Agency. Can you tell me more about that work with government organizations?
Sure, it's my pleasure. So we've had the pleasure over the years of having funded work, both as funded by the U.S. Environmental Protection Agency, also by the state of Missouri, and by some other state agencies along the way. Okay. And with this type of work, again, it's largely the focus that I mentioned of doing the science or the approaches to the science and refining those tools in our toolbox to do more effective science towards air quality management. Okay. I have also had the pleasure of serving, as you mentioned, on the U.S. EPA's Science Advisory Board. And again, it shows the U.S. structure of if we're going to have a regulation about the environment, we want to make sure it's based on sound science. So that board was essentially where the science was vetted before EPA would issue a regulation to really ensure that it would hold up with regard to being based on sound science.
I don't know if you're willing to speculate, of course, in the United States, you deal with a lot of different governmental regulatory bodies, and that, of course, changes relatively frequently with our elections. We've recently had one of those. How do you, as a researcher, as an advisor to these kinds of organizations, how do you, anticipate and, sort of prepare yourself for those kinds of changes to be sure that your work can still be impactful in the way that you want it to be?
The key is keeping your eye on the science and on the science that's policy relevant. That's really the crux, I think, in this case. There's so much great science that could be done. There's so many people doing all kinds of great science. It often has a very long-term effect, which we need that kind of science. And then there's the other type of science, like what we engage in, which is really what I sometimes call just-in-time science, to really try and inform, or at least incrementally inform, where a policy or a regulation might be going. At the end of the day, you're right. Priorities change. You can have periods of increased regulation, increased deregulation sometimes. Even a deregulatory agenda should be based on sound science. And so that's ultimately our goal, is to be part of this large community that has a voice about the science that underpins whether it's regulatory or a deregulatory agenda.
Okay, I love that, and I want to talk a bit more about those health implications, right? Of course, that's our theme this season. So sort of pushing on that a bit, I'm curious if you could speak to, really the impacts of air quality. We talked about the different diseases that are connected there. What sort of level of intervention or impact is really needed to see changes, to see improvements in human health, if you could speak to that.
Especially when you're working in other parts of the world, in low and middle income countries. Let's focus on that for a moment. There's two ways you always want to think about it. One is reducing the emissions to reduce the exposures to improve health. Usually that's a very long time scale because of the money, the financial investments that are needed to bring those controls online or those changes. So there's another plan of attack that you could be doing too. And that's other ways, other types of interventions that you can do to reduce exposures, even if you don't reduce emissions. And as an example, the obvious one is indoor air purifiers to clean up the air. But there's other types of systems like low-cost ventilation systems, which are very cost-effective compared to what you might typically see in a building with all the ductwork and piping that could be used to improve indoor air quality. And we're doing pilot projects right now in places like in Kyrgyzstan again, where we're doing a pilot project this winter in neonatal intensive care units and in a maternity ward where mothers with at-risk pregnancies might stay for weeks or months. Because if we can get these systems in place, if they can be effective in improving indoor air quality, largely driven by outdoor air coming in, then we can really reduce exposures during this critical time, which is pre-birth and in the first several days after birth.
Okay, wow. So those I guess seemingly small intervention that can have a big impact, especially for children over the course of their whole lives.
Yes.
Okay.
For sure. And as another example of the type of work we've done, we've worked with UNICEF, both in Kyrgyzstan and also in Mongolia. And in the case in Mongolia, we worked with UNICEF looking at air pollution in kindergartens. And the question again is, what needs to be done? Is it indoor air purifiers? Is it ventilation systems? Is it changing the building standards? And actually, or if there are good building standards, making sure they're actually enforced. So there's all these different layered effects of how you can get at the issue, some of which are big and expensive endeavors, and others you can chip away with relatively cost-effective measures. The other thing I like about working in those type of environments is you take Mongolia. Teachers are trusted individuals in the community. They are your best vehicle in getting back to the families, the parents, which is where most of the exposures likely occur, is in the home.
In the home, right. Interesting. Yeah, what is a good analog for that here, locally with the groups you're working with? I imagine the sort of the faith-based institutions, they are probably trusted in their communities.
Very much so. Yeah. And it's been really an enjoyable experience. The PhD candidate in my group has actually been out meeting with the constituencies, the congregation, or the church leadership, or the community groups in the neighborhood around the church that coalesce around the church as a setting where they have meetings. And really having nice engagement with people, most importantly, listening to them, also sharing back what we're doing. The bottom line is to overall raise awareness about things, the state of the situation, and things you can do to reduce your exposures.
So you wear a lot of hats. You're doing a lot of things, here locally, at the school as well as the community and globally. I'm always curious when I hear someone who is fulfilling this many roles. How do you balance all of these things, Jay? How do you just not go? Your calendar must be insane, basically. How do you keep track of all this?
The key, I think, for all this, and there's no silver bullet here, but I think the key is just a constant rechecking in on yourself, making sure that you do have that self-care in place, that you are doing what you need to do to maintain and not get burned out. For me, I'm really fortunate that my professional activities are also my passion. And so that really helps in many ways, right? If it's late at night, there's many things I could do, but often what I end up wanting to do, not just needing to do, is something related to my role, one of my roles here, whether it's research or on the education front. But I think it's just that self-awareness of continually checking in and seeing the early warning signs that, hey, maybe I need to rebalance a little bit to hang in there for the long haul.
Right. How do you maintain your level of enthusiasm, your level of passion, which is very infectious, right? Just chatting with you, I can see that this is something that, means so much to you. How do you keep up with that?
It's my colleagues and the students. Working with colleagues across the country and across the world who are deeply invested in the questions that we're asking and what we're doing keeps me very excited. A lot of people say, oh, yet another conference call or Zoom meeting or whatever. I actually look forward to a lot of them because I get to engage with really talented, passionate people about their work, whether that's about the research or about the educational mission. A really big part of it, though, is simply the students. We have amazing students here. It gives me a lot of hope for the future going forward. And I love the opportunity to get to know them and to think that all of us, the faculty collectively, are contributing in some small way to their progress and going forward. But they really have energy and enthusiasm, and that's what brightens my day.
They are really great students we have here. We're fortunate in that. Wonderful. Okay. Well, thank you. I always like to sort of close these conversations somewhat selfishly with a recommendation for myself to better understand sort of what it is you do and what you're into by getting a sort of pop culture or media recommendation. So, Jay, if you could, what book, movie, TV, anything sort of lately have you watched and thought, that's environmental engineering, that's air quality. Either that's definitely how it happens, or that's a terrible example of how it happens, and I wish people didn't think that about my field.
I'm a fan of the arts, and especially the visual arts. And documentaries about air pollution often get my attention.
Okay.
And as an example, there's one called City of Smoke by Peter Bittner. And it's a wonderful expose of the air pollution problem in Ulaanbaatar, Mongolia, where indeed I have worked for over a decade.
Oh, wow. So you know that really well.
I know it well, and I know that he's captured the issue well. But what really moves me about it is it's through the lens of the people. And really, you hear from the people about how they feel about the situation. And to me, that's very moving and very powerful when the storytelling is done through the lens of the people. So if anyone else out there has a good air pollution documentary, point me to it.
Yes. Yeah. Listeners, send us what you got. Well, that's amazing. I'll definitely check that out because I do get more of these that are, oh, they got the science all wrong, rather than this is a really great view. Okay. Well, thank you so much for that, Jay. And thank you for visiting our lovely podcast. It was a delight to talk to you, and thank you for sharing your enthusiasm with me.
It's my pleasure, and keep casting.
Thanks.